Okay, so here's the agenda. We're going to go over, as I said, we're going to go over common CAN bus failures, troubleshooting with handheld CAN bus diagnostics tools, as well as a multimeter. And then we're going to cover troubleshooting higher level CAN protocols using some tools that we have available. And then we'll have live Q&A at the end. Okay, so just keep in mind here that when you're troubleshooting a CAN network, you need completely different tools and techniques based on whether you're looking at the physical layer or you're looking at the higher layer CAN protocol. And we're going to talk about both of those, some of the things that happen and where those kind of fit and how to troubleshoot them. All right, so here's the list of the most common problems you'll see on a CAN bus. It's important to note that some of these problems are hardware related while others are related to the CAN protocol. And we're going to go over each one of these in more detail. The first one is CAN bit configuration. So for CAN buses to understand each other, they all have to talk at the same speed. And the speed of the CAN bus is also called the bit rate. The bit rate has to be the same for all devices that are on the CAN bus. The bit rate of a CAN device is usually a software configuration setting in the device itself. To troubleshoot it, the only real way to troubleshoot it is to check every CAN device on the network and verify that you have the correct configured bit rate. There are some tools I'll show you later that can actually measure the bit rate. You cannot really get the bit rate using a multimeter. You need a more advanced tool. It is possible to do some troubleshooting on a CAN network using a multimeter. But that said, to be successful using a multimeter, you really have to be able to get to the right connection points in the CAN network. And on a vehicle, that can be difficult. And even if you can, it can be cumbersome to handle the two probes in the meter and get on the right point and get a reading. The other complication is with a multimeter is to check termination resistance or to actually validate a CAN transceiver. In a lot of cases, you have to power down the network and disconnect the node from the network itself. So using a multimeter can work, but it's not always the most user-friendly way to troubleshoot a CAN network. But that said, if with a multimeter, you can check for improper termination resistors. You can measure CAN voltages between the CAN high and the CAN low, make sure that they're correct and in range. And you can use a multimeter to check to see if the CAN device has been damaged by lightning or electromagnetic noise. And I'll talk a little bit more about that. So here's a graph of CAN high and CAN low as they might appear on a scope. In recessive idle mode versus dominant logic mode, where the actual CAN is communicating here, ones and zeros on the bus. This differential voltage is what determines if you're high or low. You got a data 0 or data 1. So it's really important that the CAN voltages are at the right level. If they're not correct, then often that can tell you that CAN high and CAN low might be miswired somewhere, or you might have a faulty transceiver. So you can do this with a multimeter or a CAN tool. Most CAN tools will tell you this. Your CAN high should be between around 2.7 and 3.3 volts, and your CAN low should be between 1.7 and 2.3 volts when data is communicating on the bus. Probably the most common problem that you'll see is related to CAN bus termination resistors. A lot of times the issue can be too much termination resistance, and in some cases, none or too little termination resistance. The bus itself should be terminated on both ends with a 120 ohm resistor. Kind of probably the most complicated part to this is that a lot of the devices you can connect to the CAN bus may or may not have a termination resistor located inside the CAN device. To test it, you can use a multimeter, and for that, you need to make sure that the power supply is completely turned off, and then you can measure between CAN high and CAN low. that measurement should be around 60 ohms between those two wires. That, like I said, some devices have internal termination resistance, but I would say the most common way I see this is that the termination resistors are somehow integrated into the wiring harness itself. But if there's 3 resistors, you're going to measure 40 ohms. If there's 4, you're going to measure 30 ohms. Ideally, you want that termination resistance to be around 60 ohms. So based on the reading, you can tell if you have too many or not enough. It's very important that you get this right, especially on the higher speed networks. If you have a network on your desk, and you have 1 or 2 devices, it's not as critical as it is if you have 20 devices in a high-speed network on a vehicle or in an automation controller. If your CAN bus is on a vehicle or it's outdoors, it's possible that the CAN transceiver can be damaged by lightning or transients. Damage is typically caused by will cause a short to ground on 1 or both of the CAN lines. So you can test that by measuring the resistance of CAN high or CAN low to ground. And to do this, you can do this with a multimeter. This is probably best done with a multimeter. But again, to test this, you have to disconnect the device and turn the power off. And then you're going to measure the resistance from CAN high to ground and then from CAN low to ground. Normally the resistance there should be really high, 1 to 4 mega ohms or even higher. If it's lower than a mega ohm, you're getting resistance in the K ohms. It probably indicates your CAN transceiver has been damaged and is faulty. Another issue you can run into is CAN bus loading. Excessive CAN bus loading is more traffic than the CAN bus can really properly handle. Excessive CAN bus loading can cause data loss or errors. In theory, you really can't overload the CAN network, but too much traffic will delay your lower priority messages, and that usually results in your application not working correctly. So for a short time, bus loads above 50% are usually acceptable, but on average, a bus load of greater than 50% should probably be avoided. Note that with bus loading, you really can't measure that with a multimeter. You need a more advanced tool to get bus load. Luckily, there's an easier way. There are some options that provide really automated, nice ways to troubleshoot CAN networks. Peak Systems sells 3 handheld CAN diagnostics tools that offer powerful troubleshooting features, and I'm going to cover all 3 of them. The first one is the PCAN-MiniDiag FD. This is a really small handheld device that just plugs into the CAN network using the standard DB9 connector. It's small, it easily fits in your hand, it has a nice display, and it can work with CAN 2.0 and FD networks. It automatically measures bit rates, CAN termination resistance, measurement of CAN bus load. It makes voltage measurements of CAN high and CAN low, and can also give you a voltage measurement of the source power. And it has a really nice display and counters for errors and data packets received, whether they're CAN or CAN FD. And it's pretty affordable. The price is under $400 for this device. I'm going to show you some screenshots that you can get from this tool. So here you can see 3 useful screens. Here, first one's bit rate. You can see that this one's connected to a CAN FD network because the nominal bit rate is 500 kilobits, and then you can see the data is up at 4 megabits. And then here you see the CAN min and max voltages. And there you go. There's the termination resistance on the network, 60 ohms. So you know you're all good there. Here's a couple more interesting screenshots. Here's a statistics window that shows you how many messages you've received. Here this is an FD network, so we've got 1,452 packets received on the FD, but we also got 30 error packets and a pretty relatively low bus load. There's also a way to look at bus load over time. And this is a snapshot over some period of time. So you can see that this is generally under 50%. The bus load here is under 50. So bus load here should be okay. Okay, they also have a tool called the PCAN-Diag 2, which is an upgrade from the PCAN-MiniDiag. It can do all the same functions as the Mini, but offers several enhancements that allow for more advanced troubleshooting. This is really a great tool for analyzing CAN networks at both the physical and the protocol layer. It can record and data log incoming CAN messages, and you can even apply filtering on CAN ID to just capture the package you're interested in. Captured messages can be saved, they can be exported, converted, and viewed by other tools if you like. For testing, you can transmit individual CAN messages back, or even can transmit back captured frame lists. What's really cool is it has an integrated 2-channel oscilloscope. It has a max sample rate of 20 megahertz. And you can use triggers on those scope signals, such as like a CAN ID, to capture scope traces of just what you're interested in. The only negative here is that the Pecan Diag 2 does not work on CAN FD networks and has a list price of under $1,000. So it's still pretty affordable. Here's some screenshots from the Diag 2. Here you can see on the left, we're just data logging incoming messages. So you can look at the messages you're receiving. And there's also a nice graphic here with bus load, and also shows where you're seeing errors. So good way to visually see where you're at in the net with your network. Here's a nice shot of the oscilloscope that's available in Diag 2. Capturing a data packet here. The third tool is the Pecan-Diag FD, which is a really nice upgrade from the Pecan-Diag 2. Part of its upgrade is it can handle CAN 2.0 and FD messages on the same network. It has a more enhanced oscilloscope with a max sample rate of 100 megahertz, much higher resolution on the screen. Interestingly enough, it also has an ability to project the screen on the Diag FD onto an external display using a micro HDMI socket. So it could be sitting on the network and you can be analyzing all this data on your PC instead of having to be right there on the network. There is also an optional charging station or dock to store it in. And roughly the list price is around $1,600 for this tool. Here you can see the enhanced oscilloscope screenshot, much higher resolution, much faster, can capture FD data. Very nice tool for analyzing CAN traffic. Okay, now we're going to talk a little bit about troubleshooting the CAN network at the protocol layer. So here's a low-cost troubleshooting tool for analyzing higher level protocols. It can provide a basic troubleshooting of CAN using a free tool called Pecan View, and it uses a PEEK USB to CAN adapter. So here you got the adapter, it plugs into a PC, and then you can connect to a CAN bus. It's really nice way to easily allow you to connect the PC or CAN network to a CAN network and start analyzing your CAN bus and CAN data. I'll give you a little more information on this. So you need the Pecan USB to put your PC or laptop on the CAN bus itself. Using the Pecan USB is really easy. You plug it into your PC, it plugs into the USB port, and you can connect to the CAN network. There's several versions of the Pecan USB to CAN. The white one here is the basic Pecan USB, but this black version is a Pecan USB that can support FD and CAN 2.0 networks. As I said, this thing plugs right into your USB port. You usually have to load a Peak driver, and once it's connected, you're able to send and receive data on a CAN bus. There's also an option for increased optical isolation between the network and the USB port. This isolation works both ways. So it protects the network from the PC as well as protects your PC from the network itself. And it's also nice because these dongles don't need a wall wart or an additional power supply. They're powered through the USB port itself. So once you've got your laptop or PC connected, you can use Pecan View, which is a free software tool that can be downloaded off our site. And it can be used with the Pecan USB to view CAN messages. So Pecan View will allow you to display and receive CAN messages, as well as allow you to send CAN messages onto the network. It can also act as a data logger, and I'm going to show you some of that. Now, interesting too is if you've captured CAN data using one of the handheld tools, you can actually display those captures with the Pecan View tool. Here's a look at Pecan View. It's a Windows application. Here you can see we've received a packet from CAN ID 01, and we've also sent a message to this node as well. You can receive and transmit packets on this network. Pecan View can also act as a data logger. Here you can see data trace of all the packets we're receiving on the CAN bus. This is a more enhanced tool. This is called Pecan Explorer 6, and it's a professional grade tool, and it can be extended with some really useful add-ins. We could probably do an entire webinar on just this product. It's very extensive. It's very professional grade. It has a lot of capability. It can record and allow data logging of incoming CAN messages, and has a pretty nice capture filters to control what you capture. There's a nice trace function, allows you to play back the existing traces back to the network. You can add symbols to make those CAN messages and their payload a lot easier to read than just looking at hexadecimal data. And then there's some really cool add-ons. There's a plotter add-on that can graphically display the CAN data from your CAN messages in real time. There's an instrument panel for arranging a variety of displays, controls, switches, and connecting those to your CAN data. And then there's add-ins that enable native protocol support for protocols like CAN-DB and J1939. I'm going to show you a couple of these add-ins. Here's just a really crowded view, but this is a typical screenshot from Explorer 6. It's got a lot of functionality, a lot of capability, can support multiple windows, which allow you to capture, display, and analyze data from the CAN network. Pecan Explorer 6 can connect to multiple CAN and CAN FD networks. So if you have 2 or 3 CAN networks, you can connect them all through Explorer 6 and analyze data between them. Here's one of the add-ins. This is a screenshot of the instrument panel add-in, which if you have this add-in, you can create graphical user interfaces and then tie that digital and analog signals up from your CAN data to a variety of these controls. You've got sliders, potentiometers, switches, there's analog gauges. And as I said, these controls can be linked to the CAN data for displaying received data, as well as allowing you to use these controls to send data. Here's the J1939 add-in. If you don't know, J1939 J1939 is an SAE standard, high-level CAN protocol, and it's used a lot with trucks and utility vehicles. This add-in provides the complete J1939 network definition to Explorer 6. So with the add-in, Explorer 6 supports all the functionality of J1939 and allows data to be sent and received from J1939 ECUs. So you could, with this add-in, you can connect to a vehicle and talk directly to the ECU and receive data from that ECU. Here's a product that I think is pretty interesting. This product's from CSS Electronics. It's called the CAN Edge. There's a CAN Edge 1 and there's a CAN Edge 2. This is a really nice, powerful CAN bus data logger. So we just did a webinar on this about a month or two ago, and we recorded that webinar. And there's a link to that webinar if you'd like to see it. I'd recommend you look at it. If you're interested in doing any CAN bus data logging, this is a really cool product. So give that a look. Okay, so that's all we had for you this morning. We're going to open up the Q&A now and try to get to all your questions. We have an upcoming webinar on CAN higher layer protocols on October 11th. Watch our website because we're going to, in the coming week or so, we're going to allow you to register for that webinar. And then there'll be a survey sent out following this webinar. So please give us some feedback on this webinar and let us know what other webinars you'd like to see going forward. Thank you for attending, and we're going to try to see if we can answer some of these questions on the Q&A.
Hi, Gary. We don't seem to have any open questions at the moment. We did answer a few in the Q&A session there. So folks, if you have any questions or if there's any things that you wished we had covered that we didn't, please let us know and we can maybe try to answer them here or follow up with more details.
We'll hang out here for a little bit if you want to.
We have, I see we have a couple folks with their hand raised. Maybe they want to ask the question. So I'm going to see if they would like to try. I'm going to start with Cohen. Hello, Cohen. You can speak if you would like. You have to unmute yourself. Okay, it doesn't look like he was there. Maybe AJ would like to talk. AJ? No, maybe people are raising their hand by accident. I'll try one more. Jack? Jack, did you have a question?
Can you hear me?
Yeah.
Okay. So sometimes I'm using a Pecan View and I end up getting a stuff error or a bit error or some other sort of error. And I can see that there's an error, but I don't know how to take that error and interpret it to understand what exactly is wrong. Like the name is unfamiliar to me. I can Google like stuff error or whatever, whichever it is. But the transition from getting the name of the error to figuring out what to actually do, I sometimes struggle with. Is there a good resource for when you get an error in Pecan View? If it's a stuff error, try XYZ. If it's a bit error, try ABC. Is there a good resource that I should be using when I get those types of errors to interpret it and understand what I need to do about it?
I don't know, Ed, if you're on, if you can answer that. I guess my first initial thought is that, Pecan View is a protocol layer tool and is not looking at some of the problems Gary mentioned on the physical layer. So if you have issues with, bus loads or error frames that are happening a lot, like there's noise or interference on the line, things like that, you can't really tell that with Pecan View. You need one of those handheld tools that Gary went through there.
I think that normally Pecan View says like it starts injecting the trace that you're taking with like stuff error messages. I think that CAN messaging has a particular, it appears like a message. I'm not sure if it actually is one, that says stuff error bidder or whatever.
Oh, so this is
Pecan-
protocol layer response. Okay, yeah.
So it says in the trace in Pecan View that there's an error. I just don't know the list of all the errors and what could be the potential causes for each of them. So I struggle to narrow down what I need to do after Pecan View has notified me that there's this error or that one. So I would like if there's some resource that can help me track down the corrective actions associated with each type of error that I can get. If there is such a resource, I would like to know about it.
I am not aware of a resource like that, but I'm happy to investigate that and talk to Pete to see if they have some suggestions for helping you through those issues.
Great.
Did you try the Peak forum?
Peak forum.
Peak Systems as a forum. I'm just looking in the forum to see if there was somebody that asked that.
So the other day I got a stuff error. So if I go on the Peak forum and I look up stuff error.
You say stuff, STUFF?
Correct.
Yeah, I mean,
sure. There's some people that have reported having the same thing. Sure. Okay. The Peak system forum will probably be the best way if I have these sorts of errors to say who's found errors like them, like I have, and what do they do about it. That's probably going to be the best resource.
Yeah, I think if you check the comment, like the most common, like we had the one slide about the most common problems, or so probably, first and foremost, you should be checking, termination. You can check sample points to make sure. Generally on the CAN network, you want all the devices on the CAN network to have the same sample point. So those are probably the two most obvious that hop out to me, as far as if you see the bit stuffing error. And then just if you can, try and isolate your CAN network to see if you can, say, remove nodes from the network, if that's possible, to see if you can eliminate the error showing up.
I'm familiar with like bit rates, but I'm not familiar with sampling. What'd you say, sampling rate or sampling position? Or I don't remember what exactly that was.
Yeah, like on the CAN network, so you would normally set up what the sample point would be, like at what point during each bit are you going to sample, and that's important that all the devices on the network, especially with CAN FD, if you're using CAN FD, it's important that all nodes have the same sample point, because there's a transition that occurs at the sample point for CAN FD. But if you're using classical CAN, if some devices are sampling, let's say at 70% and others are sampling at like 80%, you might have a device. So if you have, depending on how long your bus is, you might have some devices that are going to start detecting errors. It's probably not going to cause a bit stuffing error, but it's possible. But you're gonna have some nodes that are going to start throwing errors because their sample point is earlier than the rest of the devices. That's just something that you should be doing. It's best practices to keep the sample point the same on all the devices.
Okay. How do I detect what the sample point of a particular node is, let's say with Pecan View?
Well, sample point,
I
think you'd have to look at the configuration of each device, unfortunately, because you don't know what sample point each of the devices are using unless you actually look at their configuration. And that usually is part of the CAN configuration, along with the bit rate.
Okay. So basically the conclusion here is every device is going to have a sample point. It's basically set by the manufacturer. It should be theoretically in the documentation, assuming that you have good documentation. But if the sample points are significantly far apart from each other, you could have two devices that, when both put on the same bus, don't communicate well, or cause errors to be thrown. I actually was recently working on a vehicle that had many CAN devices on it, and very weirdly, I had a CAN keypad and I had a CAN TPMS device. And if just one of those was on the bus, there was no problem. But if both of them were on at the same time, I would get errors on the bus and everything would get delayed and so on. So perhaps that's the reason. It those sorts of things do happen. Maybe this was ultimately the root cause of why. Okay, I was not aware of the existence of sample points, so that is good to know. Are there any other like properties, characteristics that are kind of like inherent to a CAN node that might not be top of mind for an engineer, but if they didn't match each other, there could be an issue? Like, is a sample point just like one of three different things that are not bit rate, or a bit rate is like really common to use and change, and it's top of mind for most people, but sample rate is not top of mind for me. Are there a couple of other things that are also not top of mind that should be on my radar so I can debug other weird failures in my CAN bus?
I suppose there are other things like you probably want to look at, like, again, I would say look at termination. Make sure you don't have the bus is terminated on each end and not terminated somewhere in the middle.
Yeah, that's a really common one. That should definitely be on everyone's radar.
Yeah, and yeah, if you have a particular node that's failing, I guess you, like everybody would do, you would try to swap that one out or whatever. But make sure that the data rate that you're using is consistent with the bus length that you have as well. You don't want to exceed the bus length for a particular data rate.
The cable length, right? Yeah, and the other thing is spur line or stub line kind of lengths.
Yeah.
How
long are the
those
stubs?
can also cause reflections in the signals, and that's where a tool like the one of the ones that has an oscilloscope would help you see if there are reflections in the signals that are perhaps causing some communication issues.
Is there CAN FD on this network? Yes, I think so. The specific difference between CAN FD and CAN is it that it's extended, or is there a different difference between FD and regular CAN that I'm not aware of?
Yeah, CAN FD, normal CAN frames have 8 bytes of payload, and with CAN FD, the bus actually speeds up during the transmission of the payload of the CAN packet. So the header and all that stuff is still at normal bit rates, but then during the transmission of the data, it speeds up. So now you can have up to 64 bytes of data that live on the bus in the same amount of time as a normal classic CAN packet. So they are.
So you fast forward. So like you're fast forwarding an individual payload and stuffing more bytes in the same period of time.
Yeah.
For a particular message.
Yeah,
okay.
that's a simple way to think of it, but that's really what's going on. It's kind of like black magic to me. I don't know how the bus can speed up and slow down like that all the time, but that's what it does, and it works really great. I mean, but there are these things like the sample points that Ed was mentioning that are different, that are in CAN FD that are not in classic CAN, or at least not an issue in classic CAN. So that's something that should be aware of.
Yeah, I mean, one of the things that happens, and I don't know if this is what's happening in your network, but sometimes normal CAN 2.0 transceivers, when they see that CAN FD data, can throw off a bit stuffing error. Just maybe because maybe it's older and it doesn't play nice with the CAN FD data. The
Well,
interesting thing about CAN FD is it has to arbitrate on the bus with CAN classic speeds, but
So just to be clear, a classic CAN node cannot be on a network that's running CAN FD. It won't work. So you need, but you can have a CAN FD node on a classic CAN network, but it'd just be running classic speeds.
Yeah,
Great,
either
good to know.
all nodes on the network have to support CAN FD. If any of them don't, then you can't use CAN FD communication.
Correct.
but maybe that could be the issue.
Yeah, it was eventually solved with a software update on our CAN keypad. So I don't know that this would be the issue, and I'm also not aware that the TPMS thing, that the other node that was causing the problem was emitting CAN FD data. Maybe it was, but as far as I know, it wasn't. But that's interesting. I'll look into that. Thanks, guys.
Thank you. Thanks for attending.
Aha. Can you hear me now?
Yeah, we can hear you.
Yeah, we can hear you. Oh, okay, great. Still trying to figure out the Zoom app on this iPad. We had a weird situation a while back connecting our node to a vehicle, which presumably had more than one node in it. And nobody on the vehicle was returning an acknowledged signal. And so our node was constantly getting transmit errors and trying to retransmit. And our CAN transceiver on a NXP chip doesn't seem to have a mode to send without, properly waiting for an acknowledge without resending. And so it was very infuriating to try and code to, because my employer was saying, well, just, make your code, send out a CAN message without waiting for an acknowledge, which of course is against the whole idea of the CAN bus for, resiliency. And so I can't quite figure out why the vehicle wasn't returning acknowledges. Maybe it was a dedicated CAN bus for us and it was in silent mode for whatever reason. But has anyone seen something like that before? And like, what's a good way to deal with that?
Well, no, getting a lot of echo here. As you said, Greg, the whole point of it is, the ACK is part of the protocol. Are you sure the bit rate was set correctly?
Yeah.
And the sample point?
Yeah, everything was fine. I mean, I tried. Sample point? Yeah, I was. Well, I haven't really. I'm assuming that's been working okay. But the I guess that's something we could have explored. Ultimately we tried writing software that would try and figure out if a message had actually reached the output queue and had been sent, and then after some period of time try to terminate or cancel the transmit request, hoping that it would stop resending the same message. But this is kind of a fool's errand, and I still can't understand how the vehicle was not sending, was not acknowledging the messages. I mean, ultimately the solution was to add yet another node to the bus, which would acknowledge our own messages, because no one on the vehicle seemed to be acknowledging. So I don't know, it was just a really weird situation. And I've been playing with CAN bus for 15 years and I've never encountered that before.
What protocol are you using on the vehicle?
What do you mean?
Is it like J1939 or is it?
A lot of the stuff we do is CAN open, but I think if I'm remembering correctly, this one was not any particular protocol. It was just kind of a free form.
Okay, so yeah, a lot of manufacturers have their own proprietary and higher layer protocol.
Yeah, I think we were only responsible for sending out a single CAN message, and the fact that nobody was responding, acknowledging it, meant that our transceiver, our module, was in constant transmit error mode, and clogging up the bus. And so our only solution was to add yet another node on our side that would just sit there and acknowledge our single message that was going out, to the vehicle.
I mean, I guess, did you try hooking up something like Pecan View before you added?
Oh yeah,
your
we use Pecan View all the time.
Okay, and
it's funny, the Pecan View app actually has a silent mode in it, but there's no silent mode on the NXP transmit module.
Right. Yeah, right. But is there traffic on the bus when you connect it with Pecan View?
Yeah, and I can't understand how it's working, but I can't.
So everyone else.
I don't have the diagnostic. I don't have the diagnostic tools to see if those other messages are being acknowledged elsewhere. And that might have been the case. Maybe for whatever reason they couldn't see our CAN messages, and that's why nobody was acknowledging it. And if I had the right diagnostic tools, maybe I could have looked at their CAN messages and see if there were acknowledges on the bus for those, but I didn't have those tools.
Yeah, I think
the other thing would be is if it might be that nobody, you're using a CAN ID that nobody's actually listening for.
Don't they have to respond to acknowledges all the time, or does it have to make it through the filters to get acknowledged?
No, I think it needs to make it through the filters. Because if you're not actually receiving the CAN message, you're not going to want to acknowledge it on the bus.
Yeah, I mean, we were sending the right CAN message, because if we were able to send just a single message, then they would receive it, and yeah, that's true. Yeah, if we sent a single message somehow, and sometimes we could send like 2 or 3 before we'd stop ourselves, it would receive the information. So I guess it was there listening, but yeah, I don't know. I mean, maybe the manufacturer of the vehicle has had this problem, or had other CAN issues and just decided to put in a dedicated CAN bus just to talk to us, which is the battery or a battery, and for whatever reason they had it in listen only mode. But I find that hard to believe. Kind of a curveball there. I'm sorry, it's kind of out of the scope of this general conversation, but just curious.
Yeah, that's pretty unusual behavior.
Okay, I'm not crazy. All right, thanks.
Thanks,
Anyway,
Craig.
All right, thanks.
I think we are past the stated end time. We have a few folks still hanging on. I don't know if they're waiting for an answer or a question. We can go through a few more of the questions on the Q&A to see if there's folks still interested in those, and I'm trying to see. Okay, so someone is asking Felipe, is there a simple way to filter messages using Pecan tool at Pecan Viewer, other to use trace function and manually analyzing it? I'm not sure. Filter bytes and bits from each message. There was a follow-on from Felipe. So I think what you're saying can be accomplished with Pecan Explorer 6. You can filter messages. You can create symbol files to look at particular bits and bytes of each message. So you're not trying to, as Gary said, pick apart the hexadecimal data, raw data. So Pecan Explorer 6 is a great way to do that. There is a free download for a 30-day trial available on our website. you have to request the trial and then we'll send you the download. And you do need a Pecan USB interface in order to use the Pecan Explorer 6 software. So, so you do have to buy that in order to trial the software. But you do get Pecan View free, as a lot of folks have been talking about here. Let's see, referring to the PCAN FD device, you mentioned that it can return the bus terminating resistance. How and when is this test performed? And will it also measure the ground side resistance, looking for possible lightning strike damage? I don't know, Gary, do you know about the ground side resistance side of that?
I don't think it does. I mean, it measures the way it measures the termination resistance probably by calculation automatically when it powers up onto the network. But I think it just takes reference to the ground it has. So it can't, I don't know that it's a good tool for determining if there's lightning strike damage. That said, I mean, if there's lightning strike damage, CAN high or CAN low voltage is likely affected. So a good place to start looking at is where your CAN high and CAN low voltages are. But then the only other way to detect CAN lightning damage is by pulling those transceivers off the network and doing a resistance test on them. Or process elimination, have a couple on the network and see if they communicate. Start adding until you find the one that might be damaged.
There's another question. How can we zoom in on the time axis in a Pecan Explorer scope? First point, Pecan Explorer doesn't have a scope, but the Pecan Diag FD does have the scope that Gary showed the screenshot for. It's a higher resolution scope. I don't know if that screen allows you to zoom in, but it is possible to connect. There's an HDMI output from the Pecan Diag FD that you can put onto a computer screen using a screen grabber dongle on your PC. So a USB to HDMI 3.0 adapter. So that helps to see those screens in much more resolution, if you will. I don't know if you can zoom in though. I'd have to look into that for you. And let's see.
That's answering the question on acceptable bus loading.
Okay.
I mean, bus loading, you can have occasional bursts of bus loading above 50%, but in general, you don't want your bus load to be above 50%. 70% sustained bus loads most likely going to be a problem, and that the lower priority messages won't be able to get through, and then that will probably at some point break your application layer.
Right. Okay, I think that answers most of the questions that I see on chat. If anyone else has any other questions or you didn't hear your question answered, please raise your hand. But otherwise, I think we'll wrap up the webinar now, and we'll go through the Q&A and make sure we got those answers out for you.
Thanks everybody for attending.
Thank you.